What if time didn't tick at the same pace for everyone, everywhere? Welcome to the world of time dilation. This mind-bending concept, hailing from the realm of relativity, suggests that time doesn't march on uniformly across the universe. Instead, it's influenced by gravity and speed. Imagine a cosmic dance where time slows down or speeds up based on the gravitational field it's in. So, an hour on a distant planet might whiz by in what feels like minutes on Earth. Or, a spaceship traveling at near light speed might experience a year while only a month passes back home. Sounds like science fiction, right? But it's not. It's the science of time dilation, a cornerstone of Einstein's theories of relativity. Time dilation is not just a fascinating concept, but it also has real-world implications. Let's dive into them. The first theory that touches on time dilation is Albert Einstein's special theory of relativity. This theory, formulated in the early 20th century, revolutionized our understanding of space and time. It proposed a radical idea. The laws of physics are the same for all observers, no matter their speed or direction. But here's where it gets really interesting. According to special relativity, time isn't an absolute thing. It can stretch and squeeze depending on how fast you're moving. If you're traveling near the speed of light, time will appear to slow down for you relative to someone who's stationary. This is not just a mind-bending concept, but a scientifically proven fact. Experiments with high-speed particles and precise clocks have confirmed this time and again. It's like a cosmic speed limit. The closer you get to the speed of light, the more time slows down for you. So, the faster you move, the slower time passes, according to special relativity. Einstein's general theory of relativity further explores time dilation. This theory, a cornerstone of modern physics, suggests that gravity is less a force pushing objects around and more a distortion of space and time. Imagine a trampoline with a bowling ball placed in the center. The ball creates a dip or distortion in the fabric of the trampoline. This is akin to how a massive object, like a planet or a star, warps the fabric of space-time around it. Now, in this distorted space-time, time itself behaves differently. It slows down as it gets closer to the massive object, just as a marble rolling towards the bowling ball on the trampoline would slow down. This is an effect known as gravitational time dilation. So if you were to stand on a planet more massive than Earth, your wristwatch would tick slower compared to one on Earth. In the presence of a massive object, time runs slower, a mind-boggling prediction of general relativity. Before we continue with more theories, don't forget to subscribe to our channel, like this video, and leave a comment if you're finding it interesting. Your engagement fuels our exploration into these mind-bending concepts. Every like, every comment, every subscription brings us closer to unraveling the mysteries of the universe. So let's delve deeper together into the fascinating world of time dilation. Now, back to our journey through time dilation. Now let's delve into some more advanced theories. First up, quantum mechanics. This theory suggests that particles can exist in multiple states at once, only settling into one state when observed. It's like your friend who can't decide where to eat until you suggest a place. In the context of time dilation, it implies that time might not be as linear as we think. Time could be a superposition of different possibilities until an observation is made. Next, we have string theory. Imagine if all matter wasn't made of particles but tiny vibrating strings of energy. Each string's vibration pattern determines the particle it represents. This theory brings in extra dimensions, up to 11 in total. And here's the kicker. Time could be one of those dimensions, and its flow might change depending on where you are in the universe. Thirdly, the multiverse theory. It suggests that our universe is just one of many, each with its own set of physical laws. In some of these universes, time could flow backwards, stand still, or even move in a loop. It's like having multiple watches, each set to a different time zone. Finally, loop quantum gravity. This theory is a bit of a rebel. It proposes that space and time are not continuous, but made of tiny, indivisible units, like pixels on a screen. Time dilation, in this case, could be a result of these units behaving differently under different conditions. It's important to stress that these are all theories. They're the best guesses we have, based on our current understanding of the universe, but they're subject to change as we learn more. These theories open up a whole new world of possibilities for understanding time dilation. Each one presents a unique perspective on how time might behave under different conditions. They challenge our understanding of the universe and push the boundaries of our imagination. So the next time you're late for a meeting, remember, time is a lot more complex than it seems. The final theories we're going to discuss involve some of the most mysterious aspects of the universe. First up, we have cosmic inflation. It's a theory that suggests the universe underwent an extremely rapid expansion soon after the Big Bang. This expansion was so fast that it stretched the fabric of space-time, leading to time dilation. In simple terms, time would have passed slower for objects caught in this cosmic expansion. It's a bit like being on a super-fast space elevator where your wristwatch ticks slower than the clocks down at the ground floor. Next on our list is dark matter. Now this one is a bit elusive. We can't see it, yet we know it's there because of its gravitational effects on visible matter. Now here's the twist. If dark matter creates gravity, then it can also cause time dilation. The more gravity, the slower time ticks. So, in regions with a high concentration of dark matter, time could theoretically pass at a different rate than in areas with less dark matter. The third theory we're tackling is wormholes. These are like shortcuts through space-time. If you've seen the movie Interstellar, you'll remember that time passed differently near the wormhole. That's because the intense gravity around a wormhole can cause time to slow down. This means that if you were to travel through a wormhole, you might come out the other side in a different time than when you entered. Finally, we come to black holes, the ultimate time distorters. The intense gravity of a black hole can slow down time to a crawl. So much so that if you were to hover at the edge of a black hole, time would pass slower for you than for someone far away from it. It's this extreme time dilation that makes black holes such fascinating objects to study. These theories push the boundaries of our understanding and make the concept of time dilation even more fascinating. So, what does all this mean for us in the real world? Well, let's start with space travel. Astronauts aboard the International Space Station, for instance, experience time slightly slower than we do here on Earth. Though the difference is minuscule, it's still a fascinating testament to Einstein's theory of relativity. Imagine for a moment a future where we have the technology for interstellar travel. Time dilation could mean that space explorers might return home to find that while only a few years have passed for them, decades or even centuries have passed on Earth. It's a concept that's been explored in science fiction, but it's firmly rooted in scientific fact. Now let's consider something a bit closer to home: GPS technology. The satellites that enable GPS are further from the Earth's gravitational pull than we are, which means time moves a tad faster for them. If this wasn't accounted for, your GPS could be off by several kilometers. It's amazing to think that time dilation has such a direct impact on our everyday lives. Finally, time dilation also profoundly impacts our understanding of the universe. The phenomenon allows us to study distant celestial objects, such as neutron stars and black holes. These objects have extreme gravitational fields, causing significant time dilation effects that we can observe and measure. By doing so, we can gain valuable insights into the nature of the universe and the laws that govern it. In essence, time dilation isn't just a theoretical concept confined to the realm of physics. It's an integral part of our daily lives, influencing everything from space travel to our GPS devices. It's also a powerful tool for astronomers and physicists studying the cosmos. So the next time you check your GPS or gaze up at the night sky, remember the incredible phenomenon of time dilation. It's a subtle reminder of the strange and wonderful universe we live in. Time dilation may seem like a strange concept, but its effects are all around us. In conclusion, time dilation is a fascinating and complex concept. From special and general relativity to the tenets of quantum mechanics, string theory, multiverse theory, and loop quantum gravity, each theory offers its unique perspective. Cosmic inflation, dark matter, wormholes, and black holes further expand our understanding. These theories not only shape space travel and GPS technology, but also redefine our perception of the universe. While time may not tick at the same pace for everyone, it's clear that our understanding of it is constantly evolving. Thank you for joining us on this journey through time dilation.